Hello dear students and viewers, welcome back to my YouTube channel Pharmacy Melody. I am Rajan Koshik and in this video we are going to discuss about the important concept of chemistry, that is the Bronsted-Lowry acid-base concept. So without delay, let's start today's session. Bronsted-Lowry acid-base theory is one of the fundamental concepts of acid-base chemistry that defines acid and bases based on their ability to donate and accept protons. Means ये जो theory है ये सब्सटेंसेस को उनकी प्रोटॉन डोनेट करने की एबिलिटी और एक्सेप्ट करने की एबिलिटी के बेसिस पे एसिड और बेसिस में क्लासिफाई करती है. एंड दिस थ्योरी वाज प्रपोज्ड बाय जोहानेस निकोलस ब्रॉन्स्टेड, who was a Danish chemist, and Thomas Martin Lowry, who was a British chemist in 1923. So a question can arise from here that who proposed this theory? So the answer will be Johannes Nicholas Bronsted and Thomas Martin Lowry proposed this theory, and in which year? In 1923. This theory provides more details on the behavior of acids and bases. Why I am saying? Because in our previous lecture on Arrhenius theory we have seen already that the Arrhenius theory is limited to the aqueous solutions, while this theory provides details on the behavior of acids and bases in non-aqueous solution also. Now move to the what are the Bronsted-Lowry acids and what are the Bronsted-Lowry bases. Let's see. A Bronsted-Lowry acid is a substance that can donate protons and hydrogen ions to another substance. Means ऐसे substance जो कि हाइड्रोजन आयंस और प्रोटॉन्स किसी दूसरे सब्सटेंस को डोनेट कर सकते हैं, ऐसे सब्सटेंस को हम Bronsted-Lowry acid के नाम से जानते हैं. जैसे कि हाइड्रोजन क्लोराइड इज एन एग्जांपल ऑफ द Bronsted-Lowry acid. Similar to the Bronsted-Lowry acid are the Bronsted-Lowry bases. These are those substances that can accept the protons or hydrogen ion from the another substance. Means ऐसे substance जो कि किसी दूसरे substance से protons को accept कर सकते हैं, hydrogen ions को accept कर सकते हैं, उनको हम Bronsted-Lowry bases के नाम से जानते हैं, जैसे कि water. Let's see how the hydrochloric acid and water behave as the acid and bases. Here you can see the reaction between the HCl and H2O. In this case, HCl is donating the hydrogen ions and water is accepting the hydrogen ion from the HCl. Then this HCl is donating the proton, then it will act as an acid, while this H2O is accepting the proton, then it will act as an base. So water ऐसा सब्सटेंस हुआ जिसने कि हाइड्रोजन आयंस को एक्सेप्ट किया, इसलिए एक बेस है, और HCl एक एसिड है क्योंकि इसने हाइड्रोजन आयंस को डोनेट किया, जैसा कि हमें Bronsted-Lowry ने बताया. And when these two acids react with each other, they form the corresponding pairs of the conjugate base and acids. Here in this case you can see the HCl forms the conjugate base, that is the Cl minus, and this is the conjugate acid of the H2O, that is a base. So conjugate acid and conjugate base pairs are also formed during this reaction. Let's see another example. The reaction between a CH3COOH. In this case, acetic acid is donating the proton to the NH3 and forming a conjugate base and a conjugate acid. In this case, acetic acid work as an acid because it is donating the proton to the NH3, and NH3 act as an base because NH3 is accepting the proton. So in next reaction you can see there is a reaction between water and NH3. In this case, water is donating the proton and NH3 is accepting the proton. So in this case, water will act as an acid while NH3 will act as an base. But in previous slide I told you that H2O is accepting the proton and act as a base, while in this case I am telling you that H2O is donating the proton and acting as an acid. So because the water can act or can behave differently into different conditions, means sometimes it can act as an acid and sometimes it can act as a base. So these type of substances which possesses both the nature of the acid and bases are known as the amphoteric substance. And you can easily tell why the water is amphoteric and what are the amphoteric substances. You can easily explain from this concept. So now move to the next slide. Conjugate acid base pairs. So what are the conjugate acid and what are the conjugate pairs? Let me correct something here. Okay. The species that remains after the Bronsted-Lowry acid has donated a proton is known as a conjugate base. आप यहाँ पे देखिए कि जो CH3COOH है, जैसा कि मैंने आपको पहले बताया है, ये किसका एग्जाम्पल है? ये एक एसिड का एग्जाम्पल है, एक Bronsted-Lowry एसिड का एग्जाम्पल। इसने NH3 को अपना प्रोटॉन डोनेट किया और प्रोटॉन डोनेट करने के बाद क्या बचा? CH3COO-। Then in this case, this CH3COO- is the remaining species, that is the conjugate base. और ये किसका conjugate base होगा? This will be the conjugate base of acetic acid. जो आपका CH3COOH है, इसका ये conjugate base होगा। इसी तरीके से NH3 ने प्रोटॉन को एक्सेप्ट किया और बनाया conjugate acid। हम देख सकते हैं लिखा हुआ है the species that forms when the Bronsted-Lowry base, means this is an example of the Bronsted-Lowry base and it accepts the proton from the CH3COH and it forms a new species, that is the conjugate acid. So during the reaction between a Bronsted-Lowry acid and Bronsted-Lowry base, conjugate acid and base are formed and these pairs are known as the conjugate acid base pairs. So acetate ion is the conjugate base of the acetic acid and ammonium ion is the conjugate acid of the ammonia. Now move to the next slide. That is the importance of the Bronsted-Lowry theory. So Bronsted-Lowry theory is very much important and it applies to the reactions in both the aqueous and non-aqueous environment, making it more versatile than the Arrhenius definition, which is limited only to the water, as I previously discussed. The theory explains the behavior of weak acid and bases like this CH3COOH, which only partially donate or accept the proton. So these are the importance of this theory. Now here are some questions for your assessment. What are the amphoteric substances? Biphosphine is a gas, and according to the Bronsted-Lowry theory, explain the nature of water and write any 4 examples of each Bronsted-Lowry acids and bases. So you can do exercise to improve your knowledge, and these questions can be asked in your examination, and a lot of MCQs can arise from here. In our next video, we will be discussing the MCQs related to our previous videos, Arrhenius theory, and this video that is based on the Bronsted-Lowry theory. So stay connected till then, and please like, share and subscribe my channel Pharmacy Medicine. Thank you so much for listening.